Welcome back. We are at section 4.7, using CPCTC. With all of these figures drawn down below, we have two triangles and they're each connected. And I think the best way that we can solve these problems is to redraw the shapes so that we draw them as individual triangles. I think once we do that, it's much easier to see. After doing a few of these, if you feel like you can solve these problems without redrawing them, fine. But I think at the beginning it helps us to see what's going on. So I'm going to highlight this first shape, and here's the first triangle that we have. We have triangle DGF, and so that triangle has been highlighted. And I'm going to redraw it down below to where it looks the same, and it might be a little bit off, but there's my best rendition of what this triangle is. And so we want to label this D, G, and F. Okay, then we want to highlight the other triangle. Let's go blue. So we highlight the other triangle. And so we can redraw this triangle. And this is going to be H, F, and E. Alright, well, what we want to look for whenever we have two triangles that are drawn as one, we always want to look for if they share a side or do they share an angle. So that's usually what we want to focus on. So as I look at this shape, hopefully you can tell that they actually share angle G, which is right here. So angle G will be shared. And what did I do wrong? When I labeled this, it was labeled incorrectly. This is HGE. I put HFE. Let's change that to a G. Excuse me. This is HGE, and that's this triangle right here, HGE. So as I was saying, we can tell that angle G is shared on both triangles, angle G and angle G, and they're the same angle. So I can say that angle G is congruent equal to angle G, and that would be by the reflexive property. Alright, now even though all the other sides look like they're each congruent, I can't assume anything. So this is the only thing that I can assume or prove, is that angle G is congruent equal to angle G. That's it. That's the only thing that I can say based off of this drawing. On our second drawing, we're going to do the same thing. Let's highlight our triangles. Here's the first triangle. Whoops. Let's do that better. There we go. So we're going to redraw. That wasn't drawn correctly. Here we go. Now I'm getting it down. Alright, and then there's that triangle. So we have A, we have B, and we have C. Now we are told that we have a 90-degree angle, so we can put that 90-degree angle there. Alright, next, let's go to blue. We're going to highlight the other triangle. And so let's redraw this triangle. And we have point D, we have point B, and we have point C. Alright, and next, we want to look again and see if they share angles or they share sides. Now, we have to be careful here because we have angle B and angle B, but they don't share this angle. This angle B is a 90-degree angle. This angle C is a 90-degree angle. This angle B is an acute angle. So off my drawing, we see that angle C and angle B are the same. So I can say that angle C is congruent equal to angle B. And how do we know that? Well, that was given to us with the drawing. It's also all right angles are congruent. Next, I want to look for a side to see if there's a side that's been shared. And looking at the drawing, we see that side BC is going to be shared by both triangles. So here we have BC and BC. So I can put a single mark here. And so I want to say that segment BC is congruent. Now, if I name BC on the left and I'm starting at the box and then going to C, I have to start at the box and then go to B, so it's going to be CB, and that's by reflexive property. Okay, and it's shared. And there isn't anything else that we can prove here. I mean, we have angle side and angle side, or side angle and side angle, but we don't have a third side or third angle. So I can't assume anything else. I can't prove anything else. This is the only thing that I can prove. Alright, then we're going to highlight the last triangle, and we'll redraw it again. So let's get that down. So here's A, here's C, and here's D. And then we'll highlight this triangle. So here's B, here's C, and here's E. And same thing as before, we want to look for sides and angles that they share. So I'm looking, and hopefully we can tell, just like in problem 1, see how we have angle G that's used in both triangles? Here it's going to be angle C is used in both triangles. So here's angle C, and here's angle C. And again, just like in that first shape, we don't have anything else that we can prove. But what I can say is angle C is congruent equal to angle C, and that's by the reflexive property. Okay, we come to our first proof, and I think what we should do again is redraw the shape. Now, the way that this shape is drawn on the right, to me, looks very confusing with all of these marks. So let's redraw this and use our own marks, because I don't like the way they have this problem set up. So we'll just go ahead and change it a little bit. Alright, so here's our first triangle. And let's draw that. Let's draw that right here. And there's our triangle. And this is W, Z, and X. Okay, and let's draw our second triangle. And so let's draw this one over to the right. And that's W, Y, and X. Now, the other thing that I'm going to do, and again, you don't have to do this. I just do it because it helps me see it better. I'm going to draw this triangle so that it looks just like this one, so I know which letters match up with which letters. Because right now, it's still a little blurry or a little bit confusing. So I'm going to redraw this shape, except this time it's going to match what I have up here. And so when I do that, where is everything going to be? Well, W will be on the right, X will be on the left, and Y will be on top. Alright, the reason why I did that is, to me, it helps me see it better. So let's take a look at what is given to us. We're given that these two angles are the same. So angle ZXW, we'll put a single mark. It's going to be equal to YWX. Okay, and that makes sense. These two angles are corresponding angles. They're both equal. Then we're told that angle ZWX is going to be equal to angle YXW. We'll put 2 marks here. These 2 marks are the same. So now we have angle, angle, and angle, angle. So in statement 1, let's draw an arrow down. This is going to be given to us. Okay, and so our plan here, our plan is to prove that these two sides are each congruent. We need to first prove that the two triangles are congruent. And then we can use CPCTC to prove that corresponding sides and angles are congruent. Hopefully you can tell that this side is shared on both triangles. So this side is shared. Now we have to be somewhat careful when we say that. We're going to say that WX is congruent equal to XW. Okay, and that's going to be by reflexive property. And the reason why we say that is that this segment is equal to itself, it's shared. Okay, and then for statement 3, now we have these two triangles are each congruent. So triangle ZXW is congruent equal to triangle YWX. That's by angle side angle. And statement 4, I can now prove that ZW is congruent equal to YX. And that's going to be CPCTC. Okay, next shape. Well, again, let's highlight these triangles and separate them. And so we can draw this triangle here. There's L, there's M, and there's N. And then let's redraw the other triangle. And M. And there's O. Okay, and what are we told, or what are we given? So let's circle all of this, draw the arrow down. We're going to put given. We also want to mark that. So we have angle L and angle O. We'll put a single mark and a single mark. We have LMN and ONM. Let's put 2 marks and 2 marks. So right now we have angle angle and angle angle. Well, hopefully from the drawing you see that MN is shared on both triangles. So we can show this as MN and MN. So we're going to say that MN is congruent equal, and actually I would have to say this backwards. We're going to go NM, and that's going to be by the reflexive property. And next we can say that these two triangles are each congruent. So triangle LMN is congruent equal to triangle ONM, and that's going to be by angle angle side. Now since I want triangle LMN, note I went from 1 mark to 2 marks to 0. So 1 to 2 to 0. So it's not OMN, it's going to be ONM. And then last but not least, we want to prove that corresponding sides and angles are congruent, and so we can say that by CPCTC. Okay, our last proof down at the bottom. Again, let's highlight and separate. So where can we draw this? Let's draw this right here. There's A, there's C, and there's D. And we want to highlight the other triangle. There's B, there's C, and there's E. So next, we want to mark with what's given. AC is congruent equal to EC. And angle A is congruent equal to angle E. And so we have angle side and angle side, or side angle and side angle. Hopefully you can tell that angle C is being shared on both triangles. So here's angle C and here's angle C. Let's put 2 marks here. And so now we have enough information to prove that these two triangles are each congruent. So we'll draw the arrow down. We're going to put given. Statement 2, angle C is congruent equal to angle C. That's by reflexive. And these two triangles are each congruent. Triangle ACD is congruent equal to triangle ECB. And that's by angle side angle. And then the proof part, let's circle it. And this is going to be by CPCTC. Alright, the algebra review, let's definitely solve these problems. We're going to use FOIL. So we get x squared, x times x is x squared, minus 2x plus 3x minus 6. That gives us x squared plus x minus 6. Foil this one, we get 2x squared plus 4x. And then we go underneath. That's going to give us 5x plus 10. 2x squared plus 9x plus 10. X plus 4 squared would be x plus 4 times x plus 4. X squared plus 8x plus 16. Now we're going to use the same FOIL process. This time we have square root. So watch what happens here. 5 times 3 would give me 15. 5 times negative 4 rad 2 is negative 20 rad 2. Rad 2 times 3 is not rad 6. It's going to be positive 3 rad 2. Rad 2 times 4 rad 2 would be 4 rad 4. Next, we want to combine like terms. So 15 for right now is alone. We're going to add up negative 20 rad 2 plus 3 rad 2. These are like terms. That gives me negative 17 rad 2. And then minus 4, and then rad 4 is actually going to be 2. So now I have 15 minus 17 rad 2 minus 8. And that would give me 15 minus 8 is 7, so 7 minus 17 rad 2. Problem 5. 5 times 5 is 25. 5 times negative rad 2, negative 5 rad 2. Rad 2 times 5, positive 5 rad 2. Rad 2 times negative rad 2, negative rad 4. Now this is called a difference of squares. And so when that happens, the middle term is always going to cancel each other out. So when we add these up, this is just going to be 0, so it's gone. Rad 4 is 2, and that gives me 23. Rad 3 times rad 3 is rad 9. Rad 3 times rad 16, rad 18. That gives me negative rad 18, and then negative rad 36. Rad 9 is 3. Again, this is a difference of squares. Rad 18's cross out, and then rad 36 is 6. 3 minus 6, negative 3. Thanks for joining us. See you next time.